Hi. I thought I would break out the molecular models today before we start talking about shapes of molecules. These are vintage. I bought these when I was in college, so they are pretty old, but they still work. And if it helps you to visualize, you can get yourself a little set of these. There's a few at the school, so don't go ahead and buy them because we'll probably use the ones at the school eventually. But um, these are the atoms, and these only do one bond, and so this could be like a halogen or something like that. And here I used the bigger connectors just so they would be a little bit easier to see. But this is a linear structure. This is like chlorine gas or bromine or hydrogen, okay? And so anything that only needs one bond when it's bonded to something like itself, okay? And so you see that we call this the linear shape. It's 180 degrees, and it's really kind of one of the more boring ones. Okay? So, moving on, here is your trigonal planar, and you can see, ooh, it's flat as a pancake. It all exists in the same plane. This is the boron trifluoride that you'll see. You'll see a whole video about this structure. This is trigonal planar, like that. And then the other way this can work is if you imagine that that is an unshared pair of electrons, this is a bent structure, okay? And this is what we see on water. But water has two unshared pairs, so I'll show you that here in a second. So this is trigonal planar, something like BH3 or BF3 or BCl3. Notice the B there. B is really where we find this right here. And then if for some reason it has an unshared pair, that's a bent structure. The angle here is 120 degrees. Okay? And then if there's an unshared pair, it is slightly less. These get bent down because the unshared pair has a lot of field. Okay? So we've done linear, we have done trigonal planar. That leaves 4 attachments. Okay, so this is tetrahedral. This is your basic carbon tetrahedron CH4. The angles are 109.5. See how that exists in 3 dimensions? So that's a new thing. And that's why, okay, so if I have this guy flat and that guy flat, you see how there's one coming back towards me and one coming out towards you. The one going away from you is your dotted line, and this is your triangle. And so that's why we draw it that way, to show that the fact that it's in 3 dimensions. Okay? So if I do this, that is trigonal pyramidal, okay? And that would be something like ammonia, NH3, that has an unshared pair up on top. And the angle goes down a little bit from 109 because, again, like with the previous thing, when you have an unshared pair up here, it bends everything down, okay? And then there's one more we look at, okay? And that is water, and it's not water, it's bent, but this is the structure that we see with water, okay? And so you see here, you've got the 2 unshared pairs, you've got 2 left, and so there's your O, and then there's an H, and there's an H, and you see that that kind of lays flat on the ground because these little nubs are not the best representation of unshared electron pairs because unshared electrons, they don't have any mass, they just have field, okay? So it's not like, you're going to be propped up on a set of electrons or something, okay? So that's the structures we get out of the tetrahedron here. You get the tetrahedral, you get trigonal pyramidal, and then you get bent, okay? And so the next one to go up is 5, okay? Now, give me a second. I'm having to reconstitute this one. Okay, so this violates the octet rule, obviously, okay, because you've got 5 things around, which makes it would be this central atom has 2, 4, 6, 8, 10 electrons around it, okay? Something like phosphorus pentafluoride or something like that. I believe that's the structure that I showed you, okay? So this one is going to be trigonal. So look for, here's your triangle around the belt at 120 degrees, bipyramidal, okay? So you get 2 pyramids, one on the top and one on the bottom. Trigonal, bipyramidal, because you got a top pyramid and a bottom pyramid. Now, take one off, you got a hobby. You got a hobby horse seesaw. I believe AP calls it seesaw. Used to call it hobby horse because you know go back and forth like this. Once, as I think I said in the video, I called it seahorse one time too, but let's just call it seesaw because it makes a nice little seesaw shape. When you take another one off, that is T-shape, and there's your 2 unshared pairs. Take another one off, that is linear. Okay, so to review for this one, everybody's here, trigonal bipyramidal. Take one off, you got seesaw, not seahorse, seesaw. Take 2 off, you got T-shape. Take 3 off, you got linear. Okay. Now here's the big guy right here. This is octahedral. It has 1, 2, 3, 4, 5, 6. Okay. So I know what you're thinking because you're very smart and you're thinking, well, if this has 6 things around it, why is it known as octahedral? Well, because you can draw a square here, boom, 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 around the belt here, and then you make a pyramid, and then you can do another pyramid down on the bottom. So it's not a trigonal bipyramidal because that pyramid has 3 sides on the bottom. But no, you make 2 4-sided pyramids, and so 4 and 4 is 8, and so therefore you're octahedral. So you got a pyramid with 1, 2, 3, 4 sides facing up, and a pyramid with 1, 2, 3, 4 sides facing down. Now, you take one off, and you have square pyramidal. You take 2 off, and you get square planar. And those are really the only 3 structures that are based on the octahedral, okay?